Hey guys, welcome back to the channel. Today I'm going to talk about something that I feel is pretty interesting. Um, and you may have come across this, you may already know what it is, but I'm sure a lot of people don't. So we're going to talk a little bit of astrophysics today. Basically Lagrange points. So have you ever looked at the star citizen map and seen the L1, L2, L3, L4, L5? And be like, what the hell is that? Why did they call it that? You know, what is that even about? Why don't they call them like, asteroid thingy one or whatever, instead of this L1 thing? Well, the L means Lagrange, and let's take a look at the map and we'll see what we're talking about here. Okay, so looking at the map, we can see that we've got all these L's everywhere. There's obviously, Crusader, Hurston, ArcCorp, Microtech, right? So I'm sure most people kind of figured that out. What they don't probably get is maybe, why they're there or why they're called L this, L that, to understand that, we need to look at a NASA website that I have found. You just switch over to that here. Okay. So I'll post this link in the description so you can take a look. Let's have a look at this. So this is, anyone can look at this website. It's on the NASA website. It's called What is a Lagrange Point? This is a really nice little simple diagram that kind of explains to you what the Lagrange points are. And there's a little blurb down here that we're going to read, okay? So basically, Lagrange points are positions in space where the gravitational forces of a two-body system, like the Sun and the Earth, produce enhanced regions of attraction and repulsion. They can be used by spacecraft to reduce fuel consumption needed to remain in position. They are named in honor of Italian-French mathematician Giuseppe Louis Lagrange. There's actually 5 special points where a mass can orbit in a constant pattern with 2 larger masses. Okay, the Lagrange points are positions where the gravitational pull of 2 large masses precisely equals the centripetal force required for a small object to move with them. That's basically it in a nutshell. So of the 5 Lagrange points, 3 are unstable, 2 are stable. The unstable Lagrange points, labeled L1, 2, and 3, lie along a line connecting the 2 large masses. Let's just have a look at that. So here we are. So like you've got the Earth, you've got the Sun, and you see you've got L1, 2, and 3, right? And they're all in a straight line. If you draw a line between the Earth and the Sun, on that line lays L1, L2, and L3, okay? The stable Lagrange points, labeled L4 and L5, form the apex of 2 equilateral triangles that have the large masses at their vertices. L4 leads the orbit of Earth, L5 follows, okay? So L4 leads the orbit of Earth, so the Earth's going around this way, anti-clockwise, and then L5 follows, right? So that's just the convention. They label this L1, L2, L3, L4, and L5. So sort of put that into your memory for a second, and now if we switch back to the map in Star Citizen. Alright, and let's take a look at, for example, Hurston, okay? So if we just zoom into Hurston, now we zoom out a little bit, what have we got? We've got L1 and L2, right? Just like on the diagram. You see the L1 and the L2. Now if we zoom out a bit further, what else do we have? As well as the L1 and the L2, we've got the L3 all the way over here on the other side of the Sun, and we've got L4 and L5. And if we take a look at the website again, you can see the L4 and the L5. So that's exactly what we're seeing in the map here, okay? L1, L2, and then L3 on the other side, and then L4 up here, L5 down here. So these are basically the Lagrange points of the planet Hurston with the star Stanton. And you'll see that same pattern repeated. So if we look at Crusader, you see the L1. Now there's no L2, interestingly, there's no L2 here, but there is L1, there's L3 on the other side of Stanton, and then we have L4 and L5. Okay, and similarly for ArcCorp, of course. Again, you've got your L1, your L2. On the other side of the star is L3, and then you've got your L4 and your L5 forming those apexes, right? Those vertices. Now, Microtech, I guess, is too far out to have collected anything in its Lagrange points. So, I mean, that's basically why 2 is missing for Crusader, for example, because it just didn't collect anything over there. But Microtech is very far out from the star compared to the other planets, so it managed to get just the L1, but it didn't. Nothing collected in its L2 or 3 or 4 or 5, you know. So that's why we only have the 1 there. But the others, you know, like the prime examples, like Hurston is a really great example. You know, it's your classic sort of Lagrange point positions. Okay, and basically it's kind of a balancing of the gravitational forces. So just wait for these to fade out. This is kind of like where the forces balance between the planet Hurston and this. I'm talking about gravitational forces between the planet and the star. So it's kind of like a little sweet spot is sitting there. You know, you're being pulled equally by the planet and equally by the star, and this is kind of where you settle. You know. And then this one, you know, it's like the centripetal forces are balanced by the attraction of both. And same for this and this. The centripetal force here is balanced by the gravitational attraction of the sun and the planet, the star and the planet. And same for this one, and then same for this one. Okay, so it's basically a balancing of forces. That's all it is. So if we take a quick look back at the website here. So here's a little interesting nugget. Objects found orbiting at the L4 and L5 points are often called Trojans after the 3 large asteroids, Agamemnon, Achilles, and Hector, that orbit in the L4, L5 points of the Jupiter-Sun system. There are hundreds of Trojan asteroids in the solar system. Most orbit with Jupiter, but others orbit with Mars. In addition, several of Saturn's moons have Trojan companions. So you get basically asteroids that settle into that position. And that's basically what they've done here in the game. That's why when you look at these, when you zoom in on them, they're just asteroids. You know, that's really all they are. And it's a good spot to put a station, because as I mentioned earlier, you know, it reduces fuel consumption for keeping it in orbit, right? For keeping it in that orbital position. So it's like the best way I can describe it, as I say, is like it's like a little sweet spot. This is the most economical position in the star system, or one of the most economical positions in the star system to put a space station. Is exactly, and you know, the asteroids have found that naturally, which is obviously what would have drawn the space station builders to that point. I mean, they would have calculated it and gone there and found all the asteroids. So that's why there's asteroids there, because that's where they would naturally settle, and that's why there's a space station there, because it naturally would settle there. It needs less fuel to keep it in a stable orbit. Okay, so that's why they're there. It's really interesting that they went to that level of detail in terms of astrophysics, and put all these Lagrange points in. But that's basically what this means. It means it's one of the Hurston Lagrange points. It's Lagrange point 4 from that NASA diagram. You know, Crusader Lagrange point 4 here, ArcCorp Lagrange point 1, you know, and so on, right? So that's what it is. I won't go on anymore. I'm pretty sure you get it now. But if you want to read more about it, I'll put the link to that page in the description below. There's also a link on that page for anyone who wants to get more deeper into the actual math and the physics side of it. They actually have a paper that kind of goes into a lot more mathematical rigor on the subject. So anyway, so that was pretty interesting. I've never really seen anyone kind of talk about it before, really. But that's what they are, they're Lagrange points. Alrighty, so I hope you found that interesting. It just kind of makes more sense of the star map. I mean, it's obviously a convention that they're intending to use because it's always been there. So it's going to be there for as long as the game exists, you know. So I just figured it would be kind of interesting and useful to know that that's why they're there and that's what they are. So hope you enjoyed that. Thanks for watching. I'll see you next time in the verse.